Hi, class. Today we are introducing natural deduction. And I mean this as much more broad and I guess with more significance in some sense than just introducing 3.1. But what you should note is that it's telling by the syllabus that we are basically spending a week and a half of class time just on 3.1. And in a normal, if this was a Monday, Wednesday, Friday class, that would be 4 to 5 classes, etc. And so we're slamming on the brakes and slowing down to a glacial pace very intentionally, not because the stuff is necessarily super difficult, but because in some senses we're going to be doing natural deduction for the rest of the semester. That natural deduction is going to be pretty much the totality of exam 2, pretty much the totality of exam 3, and about half of exam 4. So this is about the most important thing we do in formal logic. And there's a lot of different names for what we're doing here. But most generally, you should think in terms of proving why an argument is valid. That's way too vague to be a formal definition, but it really helps us get into the ballpark. Because notice, start with the assumption that the inference is valid. We could determine that very easily using truth tables, as we know. But knowing that something is valid is very different than knowing why it is valid. Why is the key question in philosophy. But just more generally, think of the difference between, say, knowing that a medicine works and knowing why it works. The latter is a much richer. It's going to give you a lot more information, help you discover other truths and knowledge in medical fields, etc. And so natural deduction is not mere validity. We already know it's valid. Instead, it takes it in terms of proving that it is valid, that is showing why and how. So that's the general idea of what we're up to. What we're really doing in terms of method is showing that the conclusion follows from the premises through a series of inferences. And to bring up a mathematical analogy, if any of you have done geometric proofs, such as proving triangles are similar, etc., methodologically it's very similar to that. And so we're going to, if we want to know that a conclusion follows from the premises, what we're going to do is show that in a series of steps, in a series of intermediate inferences, it can be done. And the way to do that is to use basically the rules of inference. So there are 10 rules of inference, 9 in your textbook. But like the rest of the Gustafsson Ulrich, it divides and first does the inferences for dot, wedge, and tilde, and then afterwards it'll go back and catch the ones for horseshoe and triple bar. It's a really nice way to divide things up, and it makes natural deduction much simpler in some senses. And that's one of the reasons I selected this textbook. But in general, if we learn how to do it with just the first rules, if we learn what it means to use them and to use them properly really, really well, the rest, as they say, is history. If you set your foundations well, the rest should come pretty easily. And so that's why we're just crawling along at a very, very deliberate, slow pace on 3.1. And so in 3.1, as I mentioned already, it's going to introduce several rules of inference. And what's really important is to just genuinely study the form of the inferences. That's kind of what we're focusing on this week. When can we make this kind of inference and when can we not? So part of that has to do with recognizing that these rules of inference are written in lowercase, and we must be really careful about that. And so the one I like to start with is disjunctive syllogism. All of these have abbreviations. Disjunctive syllogism is DS. And the form is P or Q, not P, therefore Q. So what that means is, note the lowercase. Any inference of this form is a good inference, is a valid inference. Anytime I have something that fits the form of the premises, I could conclude something that fits the form of the conclusion. And so, how to put it? The most basic version, if I have an atomic statement, A or B, and I know not A, I can also conclude not B. Well, that's pretty simple and straightforward. But here's another one that's perfectly fine to do. If I know that if A or B, A implies B or C, and I know it is not the case that A implies B, then I also know C. That's perfectly fine too. And so how do we start thinking about that and realizing when it's okay to do disjunctive syllogisms in these ways? The practice this week, the weekly exercises, are basically just to really realize what fits these forms and what doesn't. So again, the form is that. So a really good practice with this rule and all the rules, autofocus, is to just go through and say, what does this say? It's lowercase p and lowercase q with a wedge in between. And so the way you should really read this, in fact, the way you have to read this to read these rules correctly, is to say anything of the form P wedge Q, or put another way, any statement whose main operator is a wedge. And so forget these other two for a minute. S and T or R or C if and only if not T. This big ugly thing right here is of the form P or Q. And just all it takes is a main operator of a wedge. Notice it's a little messy. If P, then it is the case that A or Q is not of this form, because the main operator here is a horseshoe. And so again, what we need to read this as is anything of the form P or Q. Put another way, any well-formed statement whose main operator is a wedge, any disjunction. But given that, we have to play a matching game. The second thing that is required for a disjunctive syllogism is anything of the form not P. What does that mean? Anything that is a negation of everything before the wedge. That's how I read that. A negation of everything before the wedge. So to take a really, it seems like a tricky case, but it really shouldn't be. suppose I have not T or R. Is that of the form P or Q? Yep, sure is. But what would I need to do a disjunctive syllogism there? It has to be a negation. And it has to be a negation of everything before the wedge. Don't get creative on me. So what's everything before the wedge? Not T. The only thing I could do a disjunctive syllogism with is a negation of everything before the T. So what would it be? You might want to pause here and think about it. The only way we could do a disjunctive syllogism is also if we had a premise of the form not T. Notice if I just had T there, I know a lot of you are thinking, wait, isn't not T the same as T? We'll get to that later. But to actually follow the valid form of disjunctive syllogism, we have to have a disjunction, which this is, and we have to have a negation, which this is. And again, you read the general form as a negation of everything before the wedge. And so that's what we would need to perform a disjunctive syllogism. And again, I cannot emphasize enough the importance of thinking of these rules of inference in terms of general forms, and that's why we have that little exercise sheet this week. So I'm going to go over all the rules in this way relatively briefly, but then we'll actually look at how to bring them together and do what's called a proof. So, but a couple more with disjunctive syllogism. If I had M, that is a weird looking M, M and N, or not C, let's try, could I do a disjunctive syllogism if I had this as a premise? Hopefully you realize the answer is no. Why? Because what type of statement is this? This statement is not a negation. This statement is a conjunction. It's saying M and not M and N. If you did the truth table, you would realize that yes, that's the main operator. So, however, if I have that, then I do have something of the form not P, which is to say a negation of everything before the parentheses, which means from that I can conclude everything before the disjunction, I meant, not parentheses. And if I have that, I can conclude everything after the disjunction, in this case, not C. But again, think of it in terms of I need anything of the form P or Q, that is any statement whose main operator is a disjunction. Then I need a statement of the form not P, which is to say a negation that negates everything before the disjunction in the previous premise. And then if I have that, I conclude Q. This is the part we haven't talked about yet. What's Q? Don't get creative. Everything after the wedge. So if I had, let's just do a silly one, one more here just to make sure we're all on the same page. If I had T, if and only if not C, or M and it is not the case that C implies S, is that of the form P or Q? Yes, main operator is a wedge. It's disjoining the parentheses in the bracket. Okay, so what would I need to perform a disjunctive syllogism here? I would need not P. That is a negation of everything before the parentheses. See if you can figure out what that would be. Again, go ahead and feel genuinely, you pause it and think about it. In this case, it would be not the case that T if and only if not C. Once I have that, I'm still doing dots instead of ampersands, I apologize. Once I have that, what would I conclude? Q. What's Q? Everything after the disjunction, in this case M, and it is not the case that C implies S. That would be the one and only possible correct disjunctive syllogism here. So really, really need to emphasize what the lowercase entails and what it doesn't. We're going to briefly go through the other ones in the general ways, not as less detailed than that, but hopefully you're starting to get the idea. Next rule is called addition or add. P is what is required for addition. And you say, wait a minute, P doesn't seem to have any operators there, which means what does P represent? Any well-formed formula. Literally any well-formed formula is required for addition. One thing you'll start to realize is, well, that means we can always do addition, so we're going to have to start doing strategy, because just because I can do addition doesn't mean I should. But from P, I could conclude P or Q. Here's a weird mistake people do sometimes. Addition has the word add, and so they think of the word and. This does not conclude a conjunction. This concludes a disjunction. In fact, P, therefore, P and Q is clearly invalid. If you don't believe me, try it on the truth table. However, P, therefore, P or Q is valid. Again, try it on the truth tables. Why? Because for a disjunction to be true, it just requires at least one of the disjuncts to be true, which means that if I already know P is true, then trivially I know the disjunction is true. So here are some, let's say I have not C as a premise. Is that of the form P? Yes, everything's of the form P, which means I could do the following additions. I could do not C or M, no problem there. If I really want, I could do not C or not C. That would be weird. I could do not C. Oh, why can I do these? Because what's Q? Anything. P or Q just means anything that's a disjunction whose first disjunct is P. So P or F, and it is not the case that T and not S. For instance, is that a valid addition? Yes. Again, what's required? Not C has to become everything before the disjunct, and it just has to stay main operator of C. So that's addition. Addition is the loosest rule in some senses, because you could always do an addition. Having said that, that's going to remind us we need strategy too, because just because you can do an addition doesn't mean you should. You're not going to get anywhere in a proof if your first 5 steps of the proof is to do a bunch of random additions. We will talk about strategy in a few minutes. So let's introduce the other two of the kind of normal rules, and just in terms of what they say. Conjunction. Conjunction, if you look at it, you need a premise that says P. Just like addition, what does that mean? Any well-formed formula. It also needs Q. Oops. What does Q mean? Any other well-formed formula. If you know that P is if you know that P is true, and you also know that Q is true, well, unsurprisingly, you know that P, and Q is true. So what makes for a valid conjunction then? I need 2 premises, and I need to conclude a well-formed conjunction whose first conjunct is everything on the first premise, and whose second conjunct is everything on the second premise. That's it. So, for instance, if I have M or N as a premise, and I have S and T as a premise, then I could do a conjunction and conclude M or N, and it is the case that S and T. That would be perfectly fine as a conjunction. In fact, I could also combine them in the opposite order if I needed S and T first for some reason, etc. So that's conjunction. Again, we'll talk about when we use them in a minute, but let me mention the other two rules. Simplification. If you have a premise of the form P and Q. Now, what meets that form? Any well-formed conjunction. Anything of the form P and Q means any well-formed conjunction. From that, I may conclude P. If I know P and Q is true, then of course I know P is true. And if you're going to ask, can I conclude Q? No, and we'll talk about why that is in a second. So we read P as everything before the conjunction. So to take a trickier one, if I have A implies R and T, then I can simplify it to everything before the conjunction. A implies R. So that's simplification. Those are the four kind of normal rules. One that your textbook uses that a lot of logic texts don't is excluded middle introduction, or EMI. You don't even need any premises for it. At any point, you could introduce something of the form P wedge not P. So no premises required. Why? Because this is a tautology. Remember we talked about tautologies? What is true of a tautology? It's impossible that it's false. And so you can always use it as a premise if you need it. If you need everything as a dog or a non-dog as a premise, you got it for free. And so what do we have to conclude? This says it has to be a disjunction whose second disjunct is a negation of the first disjunct. A disjunction whose second disjunct is negation of the first. So, for instance, you could have not R or not R. That's fine. Or you could have M and N or not M and N. Notice the parentheses are important there. Second part has to be a disjunction. So those are fine with excluded middle introductions. All right, now you might be saying, wait a minute, can I introduce something of the form not P or P? No, not yet. And again, we'll talk about why in a minute. So I guess we'll talk about it now. Those are the 5 rules that are introduced in 3.1. We haven't talked about how to use them or why to use them in more detail yet. But I want to start with, well, why can't we use these inferences we know are good? Why can't we simplify to Q, for instance? Every logic, start with this. How many valid inferences are there? Infinite. So if this were a normal pen and paper class in the classroom, would you want to go into a test room having to have memorized, say, 400 valid inferences? No, of course not. That's insane. So the general idea is the logic book has to kind of walk a line. They have to get enough rules so that you can make all the inferences. You can basically prove all valid inferences are valid. That's called completeness, and we'll talk about that later. So they have to have enough rules for completeness Do you know how many that is? Actually, less than our textbook has, quite a few less. But the proofs get really complicated. So, yes, you can have a complete logic with basically two or three rules of inference and 2 or 3 rules of replacement. But then every proof gets super long. Like every proof gets to 20 and 30 steps. And so instead, the goal is to kind of find that sweet spot. Enough rules that you don't have to that you don't have to memorize a bajillion of them, but enough that each proof doesn't become super long. And usually it's right around, 15 to 20 is very common, and so that's what we have in this textbook. So that's what they're doing. Now, how do you make these types of decisions? And there's a very good thing that I'm going to be harping on again and again and again, because it's really going to determine strategy when we go to complete these proofs. You definitely want to keep a cheat sheet of not just the rules, but what every rule does, because every rule does exactly one thing. So if you need to do that one thing, you need to invoke that rule. And this is gonna start dipping into strategy. But let me just tell you, what does every one thing do? Conjunction. Tells you in its name. Conjunction is the only rule that builds conjunctions. It's the only rule that builds conjunctions. Again, might want to write these kind of functions down on a cheat sheet until you're used to them. So conjunction, if you have to build a conjunction to complete the proof, you're using that rule. By contrast, simplification is the only rule that breaks down conjunctions. So if you need to break down a conjunction, you're using simplification. And then similarly, addition is the only rule that builds disjunctions, roughly speaking. We'll talk about a goofy one later. And then it's also the only one that introduces new terms. That's why it's called addition. And then disjunctive syllogism is the only rule that breaks down disjunctions. So if I need to break down a disjunction, I know I have to use that one and only rule. Excluded middle introduction doesn't fit as nicely onto this exactly one thing. Generally, when you need multiple instances of the same letter or statement, you're using excluded middle introduction. So notice, and this is why I was talking about a while ago, you have to work on strategy. If you're looking at our first 5 rules, I can start any proof by doing a bunch of conjunctions. I can start any proof by doing a bunch of additions. I could start any proof by doing a bunch of excluded middle introductions. Nothing stops me from doing potentially infinite number of first steps with just those 3 rules. But why? And that's the answer. We need to start shifting to strategy and just realizing that every rule has exactly one function. If you're going to build a conjunction, it's conjunction. You're going to break one down, it's simplification. You're going to break down to disjunction, it's disjunctive syllogism. If you need 2 instances of the same letter, it's EMI, very likely. And if you want to build a disjunction, it's addition. Anyway, we're not going to do a whole lot of strategy now. Instead, we're just going to start with the very basic notion of proof. Here's what they'll always look like. If it's numbered, it's a known. So let's say I know R or S and T. And then let's say further, I know R. So again, numbers mean it's a known. And then from that, I'm trying to prove S. So what's after the conclusion, what's after that little diagonal slash there is what I am trying to conclude. Put another way, it is something we know can be concluded from this argument. We know that's a valid inference. Our job is to prove how and why using the rules of inference. So I'm going to start on the method I always approach these on. And again, your goal is to just turn this into a system. Turn it into a methodology. You do the same steps every time. You'll just about always get the right answer. So my first step is always to look for my conclusion. I'll ask, does my conclusion occur in its entirety anywhere in the premises? If the answer is yes, I know I need a breakdown rule. If the answer is no, I know I need a building rule. So let's say instead, just writing this off to the side here, if my conclusion was S and not R, then I know it would be a building rule. Because I'd say, well, does this occur in its entirety anywhere in a premise? No, which means I've got to build it. So we'll do that one next. But for now, let's say, okay, I know my S occurs in its entirety in a premise where? Premise 1, be more specific. It occurs in a disjunction. And I now say, what is the only rule that lets me break down a disjunction? The answer, disjunctive syllogism. What does that tell me? That no matter what else happens in this proof, I have to break down premise 1. So can I break down premise 1? Well, the only way I could do it is with a disjunctive syllogism. Can I do a disjunctive syllogism? Yes, I sure can. And here is where I do my double check. Is premise 1 of the form P or Q where the main operator is a wedge? Yes. Is premise 2 of the form, then I have a second premise 2, and I'll ask, is that of the form not P where it's a negation of everything before the wedge? Yes. So I can do a disjunctive syllogism there, and I'll do the notation first. This is called the justification of the line. Has to be in the right order, and then use the official abbreviations given in the chapter. So putting 1 and 2 together as a disjunctive syllogism, I have acknowledged I can do the disjunctive syllogism, so I turn my brain off and I just conclude Q. That is, I write everything after the wedge in premise 1. That's numbered because I've learned something new. I knew premise 1, I knew premise 2, now I know premise 3. I always like to say I've done 2 things with line 3. 1, I learned something new. That's awesome. But 2, I've moved my S. Remember, we're after S. Where's my S now? In a conjunction. What's the only rule that can break down a conjunction? Simplification. And I say, can I do a simplification? I think so. So I would be doing a simplification, so with line 3 and simp. So as soon as I write my justification, I do my double check. Is line 3 of the form P and Q, where the main operator is a conjunction? Yes. Then I turn my brain off and I conclude P. What's P? Everything before the conjunction. And that is what I was trying to prove. So I stopped the proof because I've got it a line that is this and only this. So I have proven that S follows from premises 1 to 2. And that's what we're doing. So again, we have to work on strategy eventually, but right now I'm more interested in just making very sure we get the form right. If I wanted, again, say instead I was doing this as a conclusion, this doesn't occur anywhere in its entirety as a premise, which means I need to build it. What's my only rule for building conjunctions? Conjunction. What do I need? A P such that it's everything before the and a Q that's everything after the and. Do I have a line that's P that's everything before the and? I sure seem to. Looks like premise 4. Do I have anything that's the form Q, everything after? seems to be premise 2, order matters, and so I use conjunction. And again, I do my double check. It's line 4 of the form P, yes, where it's a well-formed formula. It's line 2 of the form Q, where it's a well-formed formula, yes. I turn my brain off. I write P. What's P? Everything on line 4. Then I write an and. Then I write Q. What's Q? Everything on line 2. Notice if I did 2, 4 conjunction, I'd have a different answer. And so order matters with these. All right, let's do one more, and then we'll call it a day, because I really want you to work on these yourselves. But again, focus on the form and doing it right. The strategy stuff will come later. If the strategy still seems really deep, that is no problem. So let's say I know T, and it is not the case that P or F. Let us say that I further know M or N, and let us say that I further know not M. From this, can you prove N and T? So, the procedure will never change. We will get more rules, but the procedure will never change. First step, I look at my conclusion. Does it occur anywhere in its entirety in any of the premises? No, which means I have to build it. What is the one rule that lets me build conjunctions? Conjunction. So I might even write a side note over here. If I want to build this using conjunction, what would I need? I would need an N, and I would need a T. So these are called side notes. You don't get credit for them, and they're perfectly optional. But what this reminds me of is if I get N by itself and I get T by itself, I could use conjunction for the win. So now, since I know I have to get this, and I know I have to get this to get my conclusion, might as well treat this as the new conclusion. So, start with N. Does N occur in its entirety anywhere in a single premise? Yep, there it is in line 2. What type of statement is line 2? A disjunction. What's the only rule that can break down a disjunction? Disjunctive syllogism. Can I? Yes. Seems like it, using which line? 3. So I suspect I could do a disjunctive syllogism with lines 2 and 3, but I'm going to double check. And again, this is where you should start eventually sounding like a broken record. Is line 2 of the form P or Q where the main operator is a wedge? Yes. Is line 3 of the form not P where it's a negation of everything before the wedge on line 2? Yes. I've therefore confirmed I could do my disjunctive syllogism, which means I turn my brain off, and I simply conclude Q. What's Q? Everything after the wedge. And I needed that. Oh, okay, but wait a minute, I still need T. Can't complete this proof without T, so I might as well treat it as my new conclusion. Does T occur in its entirety anywhere in a given premise? Yep, sure does. Premise 1. What type of statement is premise 1? What's the main operator? Conjunction. What's the only rule that breaks down conjunction? Simplification. And so it looks like I have to do a simplification, but I do my double check. Is line 1 of the form P and Q where the main operator is an ampersand? Yes. And so I turn my brain off because I've confirmed I could do a simplification, and I simply conclude P. What's P? Everything before the ampersand. Okay, good thing I did the side note, because why was I doing that? Oh yeah, conjunction of N and T. Oh, that seems like it's okay. Let's double check. Is line 4 of the form P? Yes. Is line 5 of the form Q? Yes, because those have no requirements. So I turn my brain off and I conjoin them. I write P. What's P? Everything on the line 4. Then I write an ampersand. Then I write Q. What's Q? Everything on line 5. And then I stop my work because I've arrived at a line that is exactly my conclusion. All right, we're going to pause there. Work on this as much as you can, and then we're really the next video is just going to be a bunch of practicing proofs. But to do that, you really need to know how the rules work well. So practice that and do the weekly exercises. Then watch the Practice 3-1 Proofs video. And we'll talk to you next time.